Hello everyone. So in this session we will just continue our discussion of memory system and hierarchy. Already we have discussed how the different levels of memory is going to be organized, what is the need for the different levels, and how this cost, speed and expense, cost, speed and the size is going to vary for different levels. Of course, the same thing is repeated here. The CPU registers next level cache memory. Cache itself can be identified in three levels, either as on-chip cache, off-chip cache, and level 1, level 2, level 3 cache. Then comes the main memory. Then comes the secondary memory, which is identified as external memory, which can be leveled as magnetic disk, optical disk, magnetic tape. Okay. Now, if we just consider all the memories which are inside the cabin, then it is going to be called as the internal memory, and these are the memory where the CPU can have direct access. In coming to external memory, they cannot have direct access. Of course, the speed is going to be limited. So this line, I think, it represents how these levels are going to relate the important parameters, namely the speed, size, and the cost. So as we approach the lowermost level, the speed is going to increase, and the not only the speed, the speed and cost are going to be directly proportional. So it is going to increase as we move on to the nearest level. Okay. And then if we just compare the size, if we go away from the CPU registers, the size is going to increase in this level. So this explanation already we have discussed in the previous session. Now we will just see the various features of the memory. Okay, how we are going to classify the memories based on some features. So first we will just identify the location of the memory, where actually it is going to be located. By location, what we mean, whether it is internal to the cabin or external to the memory, or it is going to be external memory. So internal means it should be within the cabin. If it is going to be outside the cabin, it is going to be called as external memory. So some of the memories which are outside the external, outside the CPU is going to be disk tape, USB pen drive, hard disk drive, something like that. Okay, all the registers, the cache memory and the main memory will be identified as internal memory, and they are all volatile in nature. What we mean by volatility, if the power is not there, the content will be lost. So this is only coming under the category temporary storage, whereas the remaining memories will have permanent storage and they are all non-volatile. Okay, then next comes the capacity. So how we are going to rate the size of the based on the storage capacity of the different memories. Again, we can have internal memory capacity and external memory capacity. So external storage capacity is always measured in terms of byte, whereas internal memory is always measured with words. Okay, so the storage length also can vary. Then coming to the access methods, how we are going to access each memory location. So based on the type of access, we are having different classification. So the first classification is called as direct memory access, where the input and output devices are allowed to directly access the memory. So they will directly access the main memory without the help of the CPU, and this will usually implemented with the help of the DMA controller. Okay, the next access is going to be the sequential access. So in the sequential access, what we have told, the data is going to be stored serially from in the computer memory, and it will be read or location by location. Starting from the initial address, it will start going to read the next location. Like that, it is going to read the information in the memory one by one. Whereas the next method of access is random access. As the name implies, at random we can go switch over to any location, get the information. So need not be traversing start from the beginning. And of course, random access is usually prepared, and only for that reason we have the memory called RAM, which is specifying the type of access it is adopting. Then comes associative access. Here, associative access is going to be a special type of memory which always claim to be optimizing the search performance. How it is optimizing the search performance, maybe that concept will be discussed later in the last of this chapter under the topic associative memory. Okay, then based on this access methods, we have these classifications. The next important parameter is the unit of transfer. How the data is going to be transferred across different levels of memory, or what is the unit of transfer which we are going to refer to. Suppose in case if it is going to be internal memory, any data which is going to be transferred across the different levels in the internal memory is going to be identified in terms of word size. Whereas if we take external memory, it is going to be identified in terms of blocks. Okay, so we always have different units of reference pattern. One is called as line, next one we call as a block, and then we call as a page, and then we have the concept of frame. If it is from the secondary memory to the main memory, it will be referred in terms of pages, and from the main memory into the cache memory it will be in terms of blocks, and within the cache memory we are going to consider it as a lines. So we have different units which are going to be referred in different levels. Obviously, if it is going to be in registers, it will be identified in terms of number of bits. Okay, in cache memory, every unit, single unit is going to be called as a line. In main memory, it is going to be called as a block. And when it comes to secondary memory, it can be referred as a pages, or main memory can also be referred as a frame. Of course, these concepts will be discussed in detail when we are discussing about the memory unit. Okay, here the unit of transfer, it is going to vary for internal memory and external memory, where it is generically classified as either the word size or in terms of block size. Then comes the classification based on the performance. So what are the important factors which are to be considered to measure the performance of the computing system? We have three terminologies, namely the access time, the memory cycle time, and the transfer rate. So what actually we mean by the access time? So if it is going to be random access memory, it represents the total time taken by the memory devices to perform the read operation or the write operation. So usually what we will do, in which location we have to read or in which location we have to write, we will first specify the address. So given the address, it will take some time for us to store the information into the memory or get the information from the memory. So this time interval after placing the address and then getting the operation done, this time interval is going to be referred as the access time. Then comes memory cycle time. So what is memory cycle time? It is a total time required to access the entire memory block. So it is not going to be with respect to a particular word. So how much time it is going to take to transfer the whole block. So whenever the CPU is in need of a particular word, it is not going to read it as a word. Usually it will be done in terms of blocks. So what is the total time taken to get the entire block from the memory? That is going to be considered as the memory cycle time. So usually the memory cycle time will constitute the access time and also the initial and the later overheads. So prior to the read and prior to the write operation, what are the overheads involved? So that also will be accounted for the memory cycle time. Then comes the transfer rate. So what we mean by transfer rate? It is the rate of data it is the rate at which the data is transmitted to the memory or from the memory. So the rate at which it is going to be transferred. So within a given unit of time, how much bits of information is going to be read from the memory or how much bits of information is going to be written into the memory, that decides the speed. So the transfer rate is also an important parameter. So whenever we are whenever we are evaluating the performance of a particular memory level, we will be very much keen on the access time, the memory cycle time, and the transfer rate. Then comes a physical type. So what are the physical component which is going to be used to constitute that particular memory? The basic component used to build that memory, that comes under the category physical type. So usually the memory can be made of magnetic materials, or it can be made of semiconductor type, or it can be a combination of magnetic material and optical type, or it can be purely optical. So based on the physical component used to design that memory, we have the classification called as physical type. Next comes the organization. How the physical structure of the memory is going to be organized. So that is also going to come under the category of one classification of the memory feature. And then the last one, which is going to be called as the physical characteristics. So what we actually mean by physical characteristics, it refers to the behavior of the memory. So by behavior, what we are trying to conclude, whether it is going to be volatile in nature or non-volatile in nature. What we mean by volatility and non-volatility, if the power is there, whether the content is going to be retained or the content is going to be lost. So based on that, we have the characteristics volatile and non-volatile, and sometimes we also have some memory which cannot be erased. So whether it is going to support erasing feature or non-erasable. So based on these factors, we have further classifications. So always the permanent memory will come under the category non-volatile. It is a permanent storage memory, and this permanent storage memory is going to be applicable only for the secondary levels of memory, secondary storage devices. All the main memory and the cache memory, they are not going to have, they are going to have the content only in temporary manner. So that will come under the other category, volatile. Okay, now the next thing is classification of the memory. I think we have already discussed in the previous session how the memory is going to be classified. So primary memory or main memory, secondary memory, otherwise called as auxiliary memory, then comes a cache memory, then comes a register. So if you take secondary memory, all the storage devices whatever we are going to use, that will come under the category secondary storage. And the main memory Again, it is going to be RAM or ROM. There we have random access, and this ROM is also random access, but ROM will support only read, whereas RAM will support both read and read. So this RAM is again classified as static and dynamic, and this ROM, based on the way in which we are going to program that and the way in which we are going to erase the content in that, accordingly we have different classifications, namely programmable read-only memory, electrically programmable read-only memory, electrically erasable programmable read-only memory, and also we have ultraviolet erasable read-only memory. So like this, there are so many classifications which comes under the category of memory. And primary memory and main memory. So the memory which is going to be closer to the CPU is always going to be called as a main memory, and the CPU can access the information only from the main memory, and they are notable for its temporary storage and faster data processing rate, and it is usually referred as volatile memory. And of course they are going to be costlier than the secondary memory, but if you take the size, it is going to be limited. So random access memory, read only memory, already we have discussed a lot. So if you just see the random access memory, it will be available like a chip. So it will be like a kind of an add-on card which can be inserted into the port available in the exterior part of the cabin. Okay, so we can always upgrade the size of the random memory, and more the size of the random memory, that will decide the speed of the processor. So if we have enough space, working space, the swap in swap out time can be minimized, and thereby we will be able to improve the efficiency of the entire system. So we always have provide this RAM as a separate chip, and this can be considered as like a kind of an add-on card which is available in the exterior port. Then this RAM itself can be further classified as static RAM and dynamic RAM. So this is going to be classified based on the type of the component which is used to frame this memory. So in the name dynamic random access memory, the content is going to dynamically change. Why it is dynamically changing? Because it is going to make use of capacitors. Okay, so if capacitors are used, the basic nature of the working principle of the capacitor is it usually charges and then discharges. So when it is going to discharge, the content is going to be lost. So we have to periodically refresh, and then only the memory content will be retained. So here they have told if the power is switched off, the data is going to be lost. And the characteristics of dynamic RAM is it needs to be continuously refreshed. Only then we will be able to retain the data. And of course, it is lower than the static RAM, and it also holds large amount of data, and it uses the combination of capacitors and transistor as a basic building block for framing this memory. And of course it is less expensive when compared to static RAM, and power consumption also is going to be very less. Now coming to the static RAM, it is the content is the static type of RAM memory is usually built with floppies, flip-flops and other things, and usually the content stored here will be permanent. Okay, the data is lost when the power failure has occurred, but still we need not do any refreshing. So no need to refresh. It is of course faster than the dynamic RAM, and it is also expensive, and it is notable for high power consumption. Most of the characteristics whatever we have seen for DRAM, that is going to conflict here. Okay, it has a longer life and also supports larger size, and usually the static RAM is going to be framed for the cache memory, because we already know cache memory is a high speed memory. Its speed is going to be attained because of the basic component which is used here, and since it is faster than DRAM, this is going to be the best suitable memory that can be used to design a cache memory. So here we tabulate the difference between the static RAM and dynamic RAM. As the name implies, the SRAM stands for static random access and DRAM stands for dynamic random access. Of course, the access time is going to be slow here, whereas it is high here. If the basic component used here is flip-flop, whereas here we use capacitors. Okay, and because it is not using capacitors, it needs no refreshment, whereas in the capacitors, if capacitors are used, its charge is going to be lost, so we have to keep on periodically refreshing to, so then only the content will be preserved. And usually for framing the cache memory we will be using SRAM, and for designing the main memory we will be using DRAM. And of course the SRAM, already we told it is expensive, but DRAM is less expensive when compared to SRAM. It is going to support a class complex structure, whereas here the DRAM structure is going to be very simple. It requires low power consumption, and this requires more power consumption. So whatever we have discussed here, based on that we have some advantages of RAM and disadvantages of RAM. Okay, it's going to be self-explanatory, so we can just go through this and it will be clear to you. Our RAM advantages is faster in nature, less power, and it increases the performance of the system for multitasking, and of course the program is going to be loaded faster and it's suitable for performing read and write operation. Coming to the drawbacks of rom, it is volatile in nature, so it cannot preserve the data. It is expensive than the rom, and it is unreliable when compared to rom, and the size of the ram is of course limited. So due to its volatility nature, it requires the electricity to preserve the data, and of course it reduces the speed and overall performance